Good afternoon, students. I am Munshi Rashidul Islam, Assistant Professor, Department of Mechanical Engineering, JIS College of Engineering. Now, today is the lecture number 12. Lecture number 24 for the original lecture, but in the chapter-wise lecture, that is actually the lecture number 4 on the gear drives chapter. So we have already covered a lot of part of the gear drives chapter, but now today we have discussed about the different types of gear train and its application. So train value. So last day we have discussed the different types of design and designing procedure, designing methods of spar gear, parallel gear, parallel helical gear, and home gear. So everything can be discussed in the last classes. Obviously, one important point that is actually interference. Now today we have discussed the different types of gear train and its application. So now before starting the gear train, we have discussed some remaining part of the last day classes, that is actually the tooth property for 20 degrees straight bevel gear teeth. So some equations also be there, so that equation you have to be maintained and to solve the any type of problem. That means suppose some items that can I already discuss in the last classes, just like the working depth, clearance, addendum, gear ratio, or the 90-degree gear ratio, face width, and minimum number of teeth. So first one is, suppose the working depth. Working depth will be 2 by P. Now clearance will be C is equal to 0.188 by P plus 0.002 inch. Addendum of gear, that is equal to AG, is equal to 0.54 by P plus 0.46 by P by M90 square, means the 90-degree angle module square. Gear ratio, obviously you know the gear ratio mg is equal to ng by np, and obviously the equivalent 90-degree ratio, that will be m90 is equal to mg, and when lambda is equal to 90 degree, so total angle will be m90 is equal to mg into cos psi by cos lambda. Now for face width, that is equal to f, and f is equal to 0.3 a0, or f is equal to 10 by p, whichever is smaller. And now minimum number of teeth, and that will be a equation, that will be a conditions, just like pinion. If pinion is 16, gear will be 16, pinion is 15, gear will be 17, pinion is 14, gear will be 20, and if pinion is 13, and gear will be 30. Now properties of the helical gear. It's a similar type of formula that I follow in bevel gear. Similarly, in helical gear cases, another type of formula you can also be used, and the cases you have to be followed, one by one. Suppose the one cases is addendum is equal to 1 by Pn, dedendum is equal to 1.25 by Pn, where P is equal to N, Pn is equal to normal pitch, pinion on pitch diameter, that is equal to Np by Pn into cos psi, gear pitch diameter, that is equal to Ng by Pn into cos psi. And for the external gear, standard center distance is equal to, we know that center distance means that diameter of the two gears, that means the d plus d by 2. Now the gear outside diameter, that will be capital D plus 2a, and gear root diameter, that will be capital D minus 2b. And now pinion root diameter, that is equal to small d minus 2b. And now internal gear cases, center distance will be capital D minus small d by 2. Inside diameter will be d minus 2 2a. That means the center distance and root diameter is equal to d plus 2b. And on the other sides, the normal arc tooth, that will be p pi by pn minus bn by 2, and the gear base circle and the gear base radius, gear base diameter will be d into cos phi t, and the base helix angle, that will be tan inverse of tan psi into cos phi t. So these are the equation, and that took all the equations coming from the standard nomenclature standard, or some equations also come out from the empirical formula. And this is also a load versus pressure angle equations, where addendum dedendum also be mentioned. So you have to be just remember it, or you have to just mind it in your or reference, and that will be helpful to calculate the any type of problem. Now again, next you have to be considered on gear train. Now for any type of gear, in gear train value means that the two gears obviously is required, and another portion also be considered, that is called as a arm. So where the two gears and arm are there, so you have to be mentioned, and you have to be remember the gear train is actually formed. And for suppose for a pinion 2 driving a gear 3, so the speed of the driven gear is actually, so n3 is equal to small n3 is equal to n2 by n3 into n2, where capital N is equal to the teeth, number of teeth, and small n is denoted as the revolutions per minute, and T is equal to pitch diameter. So as per the equations, if the pinion is 2 and the gear is 3, so now for the case n3 is equal to capital N2 by n3 into n2, that also equal to the d2 by d3 into n2. So where n is equal to small n is equal to revolution per minute, capital N is equal to number of teeth, and D is equal to pitch diameter. So that is actually the train value. See here, the lot of gears are connected in such a way that N2 2 gear, 3 gear, 4 gear, 5 gear, 6 gear. So N6 by N2 is equal to the odd number of teeth are in upper portion. That means N2 by N3, the product of driving smooth gear product of driving tooth number whole by the product of driven tooth number. That means N2 by N3, N3 by N4, N5 by N6. That means N5, N3, N3 cancel, and N1, N2 cancel. So total number of teeth in the driving tooth whole by the product of total number of driven teeth. That is actually the train value. It is actually the ratio of this type. So if suppose one member is driver, then obviously the opposite gear will be a driven member. Similarly, if the driven member is connected with the another gear, so on that cases the driven member will act as a driver, and the opposite gear will act on that situation is a driven member. The compound gear. So a practical limit of train value for one pair of gear is 10 to 1, and to obtain the more the compound two gears onto the same shaft. That means if more than the two gears are connected in such a way that the first gear is connected to the third gear, and 2 and 3 are also the same axis and same shaft. That's why the speed of the 2 and 3 gear are also same, because the both the gears are connected with the same shaft. So that's why that type of gear is called as a compound gear. Compound reverted gear train. A compound gear train with input and output shaft in line. So as per the geometry, d2 by 2 plus d3 by 2 is equal to d4 by 2 plus d5 by 2. That means p is equal to n by d, and now putting all the value. So n2 plus n3, n2 plus n3 is equal to n4 plus n5. That means first gear and fourth gear are obviously the coaxial, and second and third gear are also connected in the same shaft. So that is actually the compound gear with reverted gear train. Now a simple problem regarding the gearbox with reverted gear train. So a gearbox which is connected, which is needed to provide the exact ratio, that is 30:1 increase in speed, and while minimizing the overall gearbox size, the input and output shafts should be in line and specify appropriate teeth number. So that means the equations are n2 by n3 is equal to 6, n4 by n5 is equal to 5. So n2 plus n3 is equal to n4 plus n5. That means if the put the all equations and should be in minimize the n3 value, since the gear ratio is to be achieved in these stages, and to avoid the interference, the minimum interference, the minimum for n3 is 16. Now if applying the governing equations, n2 is equal to 6 n3, that means 6 into 16, that means 96, and now n2 plus n3 is equal to 96 plus 16 is equal to 112. That means n to the power 4 plus n to the power 5. Now substituting n to the power 4 is equal to 5 n5, that means 112 is equal to 5 n5 plus n5, that is 6 n5. Now n5 is equal to 112 by 6, that means 18.67. So that is actually the case of the governing equations, where the governing equations which will actually apply, and the error value can be found out as per the directions, where the n3 will be 17 and 18 etc., and until it works it can be quickly determined, where in the choice, beginning of the choice, n3 will be as 1, and applying the equations that will gives in the proper way. And this is also a factorial value, where the n5 is equal to 7 by 6, and the fraction should be eliminated by multiplying the 6, and so actually indicating value to avoid the interference, that will be n3 is equal to 18. That also a equation, so where the equations is governing equation can also coming out, and putting all the value, you can get the result one by one. So just like n2 is equal to 108, n3 is equal to 18, n4 is equal to 105, and n5 is equal to 21. and checking the all value and calculate. E is equal to 108 by 8 and 105 by 21, that means 65, and 6 into 5 means 30. And now n2 plus n3 is equal to n4 plus n5, that means 108 plus 18 is equal to 105 plus 21, that means 126, and that also 126. That means the governing equation fully applied. Now lot of equations are also engaged here, so we cannot possible to solve this next classes we can discuss with a new topic and new lesson. That means the another point also be denoted here. First one is simple gear train, second one was the compound gear train, third one was reverted gear train, and last one are the remaining part that will remain, and that is actually the planetary gear train or epicyclic gear train. So epicyclic gear train, I can discuss this in the next class because the time is not available here. So next class we can discuss with obviously a planetary gear train. So thank you for today's class.